Welcome, everybody. This is 6.1. All right, unit 6.1. And let's get into some vocab. We will talk about this equidistant vocab here. Equidistant basically means it's the same distance. So like a point, if it's equidistant to two other things, it is the same distance. So you can think about it as that. And write down same distance. And if it's the same distance, that means those distances are congruent. Now we have a couple theorems in this lesson. This lesson's all about some stuff being equidistant. So let's look at this first theorem here. This first theorem is going to read it. It says, in a plane, if a point lies on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if line CP that it says here. So here's CP. If this line is a perpendicular bisector, so we see that perpendicular mark, and bisector means we have two also congruent segments in the sides. Then what this is saying, I'm going to mark this. Therefore, then CA is going to be congruent to CB. So that is our perpendicular bisector theorem. And then underneath that, we have our converse. So the converse just says, hey, in a plane, if a point is now equidistant from the two endpoints. So notice that D is equidistant from B and A because you'll look here, we have those congruent marks. So now that D is equidistant, these endpoints, then D must lie on the perpendicular bisector, which means D is going to lie on this line. All right, and this line here will then have to cut AB in half because bisector means cuts into two congruent parts. Now let's look at the next theorem. This is the angle bisector theorem. So let's just think about the words first, angle bisector. So you're going to have a ray or some type of segment that cuts an angle basically in half. Okay, so if a point lies in the angle bisector, so here's our point, we're going to call this D. If it lies in the angle bisector, which I can see I have two congruent angles here, then D, or that point, is going to be equidistant to sides. If you go back to earlier this year, when you want to measure the distance from a point to a line, you need to measure it on its perpendicular. So a line that's perpendicular to it. So I want to find the line that's perpendicular from point D to line or segment or ray AB. And so this segment here is going to now be equidistant or congruent to also DC. And then we have the converse, which says, hey, if a point in a plane lies, if the point is equidistant to two sides, so I'm given that these are equidistant, then this point lies on the angle bisector, so that way we can then prove that these two angles here are now congruent because that's the definition of the angle bisector, makes two congruent angles. All right, so let's actually see this in play here. So let's go to that next page here and let's just do a couple of these practice problems. So if we look at these first three here, so let's look at the first one, AB. It says find the indicated measure of AB and explain our reasoning. So if we look here, what I notice is these are both 6. Because they're both 6, these are both congruent. Because those are both congruent, that means this is, and because I see the perpendicular mark here, I know that this is a perpendicular bisector. Because I see that that's a perpendicular bisector, if we use our perpendicular bisector theorem, then we know that AC is going to be congruent to AB, which means if AC is 9, AB is also 9. Number 2, let's find EG. I'm actually going to highlight that one, EG. We want this whole thing here. So let's look at what's given. I see two sides that are congruent, which means F has to lie on that perpendicular bisector. So this is the perpendicular bisector theorem, but it's the converse. sorry, the converse of the perpendicular bisector theorem, which says then these two segments, EH and HG, are going to be congruent. So if that's the case, HG is 3. But if I want EG, our segment addition postulate says 3 plus 3 equals 6. Let's go number 3, SU. I see R is equidistant the endpoints, which means R must lie on the perpendicular bisector. So that means these two are going to be congruent. So this is going to be our perpendicular bisector theorem. And we're going to look at its converse. So now that we know the two at the bottom are equidistant, what we do is we set them equal. Sorry, if they're congruent, we set them equal to each other. So we're going to have 2x plus 2 equals 3x. And when we solve, we're going to get that x equals 2. Now it does ask us to find segment SU, the whole segment, which means I need to go right back up where this x is and say 2 times 2 plus 2, which is going to give us, what's that, 4 plus 2. So SU is going to equal 6. All right, let's move on to number 4 here. If I look at number 4, it says find the equation of the perpendicular bisector of AB. So bisector means it cuts it in two pieces, which means we need to, we need to find the midpoint. So we can find the middle. And then if we want perpendicular, that means we also have to find a negative reciprocal slope. And then we'll use our point slope form. So let's go do a couple of these here. The first part, our original slope, I can look at my ordered pairs here if I want to, or my rise over run. But if I look at my rise over run, I go up 1, 2, 3, 4 over 2, which is 2. So if my original slope is 2, I want to use a slope of negative 1/2. Now let's find the midpoint. Okay, so the midpoint, first I need to find these original ordered pairs. So point B is 2, 2. Point A is 0, negative 2. And then from there, let's go ahead and find our midpoint. So our midpoint is where I add my two x values together. So 0 plus 2 divided by 2. And then I'm going to have negative 2 plus 2 divided by 2. And if I put all that together, I'm going to get the point of 1, 0. So these two together, we are going to use in our point slope form, which is y minus y1 equals slope times x minus x1. Let's go ahead and figure out the equation of this line. So we have y minus 0 equals negative 1/2 x minus 1, and we clean all that up. We're going to get y equals negative 1/2 x plus 1/2. There we go. All right, just a few more on this one. All right, let's look at question number 5, 6, and 7. All right, find the indicated measure, explain our reasoning. The measure of angle CAB. So what I see is point D is equidistant the sides because I see these congruent marks here, which means D must lie on the angle bisector. So that means these angles are congruent. So the measure of angle CAD is 20 degrees. So if we look at CAB, our angle addition postulate says that this must equal 40 degrees. Now, what's the main theorem that we used here? We used our angle bisector theorem, and we used its converse. So measure of angle CAB is 40 degrees. We want to find the measure of segment DC. So DC is going to be this one right here. Now what I do notice is two angles that are congruent. They're the same measure, so I can put those marks here if I want, which means that AD is an angle bisector. So if we use our angle bisector theorem, I'll write that down. If we use the angle bisector theorem, it says then that point D right here has to be equidistant the two sides. So if BD is 5, DC is also 5. And then number 7, find BD. So let's find BD here. Here's BD. What I see is two angles that are congruent, so that means AD is an angle bisector. So if we look at our angle bisector theorem, it says that these two segments up here, BD and DC, should be congruent because D is equidistant, which means we set these two equal to each other. So 3x plus 1 equals 5x minus 1. And we're going to get the x equals 1 when we solve, but we need to put that 1 back up in the segment. So 3 times 1 plus 1 means that BD equals 4. All right, there we go. There's 6.1. We'll see you here next time.